Bismillah ar-Rahman ar-Rahim. Let us start discussing the dynamics of uniform circular motion. Previously, we talked about the kinematics of uniform circular motion. We mean by uniform motion with constant speed, circular motion, an object which is moving in a circular path. We have seen this before from kinematics point of view. We said that an object moving with constant speed, so V is constant. V is constant, which is the speed. Okay, but the direction is changing. Okay, so V always is the tangent to the circular path, so it keeps changing its direction. And we said that there is a centripetal acceleration, okay, which is acceleration towards center, and this is equal to it has a magnitude of V square over R, where R is the radius of the circular path. Okay, so this is the magnitude of the centripetal acceleration. Why do we have acceleration? Because there is a change in the velocity. Although the speed is constant, but direction is changing. Okay, changing direction. So the velocity is changing because the direction of the velocity is not constant. So this is why we have acceleration. The acceleration is the rate of a change of the velocity. This has been discussed before in the kinematics. But now let us talk about the dynamics. Because now we know that in Newton's second law, F net equals ma. So this is our object moving in a circular path. So at this point, its acceleration is towards center. Okay, this is AC. At this point, when it comes here, where is its acceleration? The direction of the acceleration is this way. Okay, and if my object is here, the acceleration will be this way. So it keeps changing its direction, but it is always seeking the center or toward the center, and this is why we call it centripetal acceleration. Okay, so according to Newton's second law, F equals ma. So this is our object. It has centripetal acceleration. So this is AC, and there should be a force, as we have seen before. This is a vector equation. So there is a force. We will call it centripetal force. It should be in the same direction as the centripetal acceleration. Okay, and this is Fc will be mv square v square over r. Okay, so this is very important result, and this object, while moving, or in order to make it moving in a circular path, there should be a centripetal force. It will be in the same direction as the centripetal acceleration. So here I can write Fc, which is equal to mac. Okay, when the object is at this position, it will be directed in this direction. So this is Fc, and here Fc will be toward the center. So in conclusion, we can say the following. If you would like to have an object moving in a circular path, you need to apply a centripetal force on that object, a force toward the center of that circular path. How much is that force? That force should be equal to m, the mass of the moving object, multiplied by the square of its speed, divided by the radius of the desired circular orbit. So let me write this very important result. In order to have an object, in order to move an object in a circular path, okay, what should we do? We should apply a centripetal force, okay? A centripetal force, centripetal force should be should be applied. We should apply that centripetal force. So I can explain it. Fc equals mv square over r, and its direction should be toward the center. So this is the magnitude of the Fc. Its direction is toward center. Okay, toward the center of the circular path. Okay, from where we can get this centripetal force? Let me give you a few examples. And this centripetal force is not extraordinary force. It is one of the forces which we deal with. Let me assume that I have this ball. Okay? I can move it in straight line. Okay? I can move it in a straight line. It is here. I can move it in a straight line. But if I want to have it moving in a circular path, I should apply a force which keeps it moving in a circular path. Now I'll attach it to a string, okay, and I can move it in such a circle. Okay, you can see that my ball now is moving in a circular path. What is the force responsible of making it moving in a circular path? Is the centripetal force. It is this Fc, okay? And this Fc is given by the tension. What do we call the force in the tension? The force in the string, we call it tension, okay? So Fc in this case will be the tension in our string, okay? By the way, this motion, we call it circular motion in vertical plane, okay? Because the ball is moving up and down. While moving it this way, we call it motion of the ball in horizontal plane. Okay. So this is one example. The centripetal force Fc can be tension force. Okay. So as I have shown you in this example of the ball and the string. Let me give you another example. We know that the moon is rotating around Earth. Okay, the moon rotates around Earth once every 1 Hijri month, every 29.5 days. Okay, so it is almost circular motion. Approximately, it is a circular motion. What keeps the moon in its orbit? Why the moon doesn't move in a straight line? Because there is a force pushing the moon, or pulling the moon toward the center of the circular path. What is that force? You can guess what is that force. It is the gravitational force between the Earth and the moon. So the Earth is pulling the moon toward the center, and this is why the moon is kept in a circular path toward Earth. So it might be gravitational force, like the case of the moon moving around Earth, and the same applies to the motion of Earth around the sun. It is also gravitational force, or the motion of satellites around Earth or around other planets. The responsible force in that case is the gravitational force. Also, sometimes we can have the static friction force as the centripetal force. Okay, static friction force. Okay, I can give you another example here, which is the case of having a car moving in a circular path. If I have a car moving in a circular path and you would like it to move in that circular path, there is a force responsible of keeping it in a circular path. That force is the static friction force. Why do we call it a static friction force? Because there is no motion outward or inward. It is exactly moving in the circular path. Okay, so there is a force preventing the object not to slide on the surface. So that is the static friction force. Okay, it might also be the normal force. It might be normal force. I can give you the example of you being a passenger in a car, okay, and the car was moving in a straight line. All of a sudden, the driver of the car will turn left, okay. In that case, in a circular exit, for example, in that case, you'll find your body little bit tilted to the right, okay, and the door of the car will push against you toward the left. So what keeps you moving in a circular orbit with the car is this normal force, which is exerted by the right door of the car on your shoulder, okay, and keeps you moving in that circular path. Let me summarize. If you would like to move an object in a circular path, you need to apply a centripetal force. That centripetal force has a magnitude of A centripetal. A centripetal is nothing but V square over R. So Fc has a magnitude of mv square over R. Fc, of course, has a direction. This direction is changing, but it is always toward the center of the circular path. And this Fc can be any of the forces. It might be tension force, it might be gravitational force, it might be static friction force or normal force, it might be electric force or magnetic force, but we don't cover this in our Physics 101 course. Thank you.